Hello students. Now we are going to discuss very important topic, that is electrode potential. In the last class already we have discussed regarding electrochemical cell, that is electron chemical energy is converted to electrical energy. So due to the difference in electrode potential between two electrodes, current flow, if the both electrodes have same potential, same tendency to lose electron, then there will be no flow of current, there is no formation of current, that is no formation of electron takes place. So electrode potential is very much important to frame the different types of electrochemical cell, that is galvanic cell. So electrode potential, it is the major tendency of an electrode to lose or gain electron. Tendency to lose electron. Tendency to lose or gain electron, that is called electrode potential. In terms of between two electrodes, which electrode has more tendency to lose electron, which electrode has more tendency to accept electron, that depends upon the nature. So electrode potential generally two types. One is oxidation potential, then second one is reduction potential. One is oxidation potential, another is reduction potential. And this oxidation potential, when it is measured, mainly it depends upon the tendency to lose electron. To lose electron. To lose electron, that means oxidation potential. To gain electron, that is called reduction potential. So this potential, when it is measured in standard state, when it is measured in standard state, it is called E naught. When it is measured in standard state, when potential, electrode potential is measured in standard state means already we have read at 25 degrees Celsius and 1 atm pressure. Standard state, this potential, that is called OX, oxidation potential. Oxidation potential and reduction potential just opposite. Value is same, but sign is different. These two can retain opposite sign, because one has tendency to lose means other has tendency to accept is less. If you high reduction for oxidation potential, low reduction potential, low oxidation potential, high reduction potential, just opposite. So that is opposite sign. In the magnitude same, but sign will be different. So oxidation potential is measured in standard state. And this oxidation potential, when between two electrodes, when you connect, that this difference of potential, that is called E naught cell potential, that is called cell potential, or that is also called EMF of cell, which is equal to always that E cathode minus E anode, standard state. E cathode minus E anode. Cathode minus anode means here this difference is in terms of reduction potential. Already I have told you in the last class, when you calculate the reduction potential, it will be always E cathode minus anode. It indicates E cathode is always greater than E and O. That's why difference must be positive. Difference must be positive. If there will be positive, then del G value will be more negative. Already you have read in your, that is in previous class, that is del G, delta G equal minus NF what? Inert cell. When inert value will be more positive, then del G value will be more negative, then the process will be more spontaneous. That's why the difference must be, but this is the cell potential between for a particular cell connected to two half cell. Then every electrodes, every element, every substance has tendency to lose or gain electron. Normally, the electrode potential is expressed in terms of reduction potential, or particular value is taken in terms of reduction potential. Generally taken as reduction potential. I will give some example that this arranging of this different electrode potential in that decreasing or increasing order. Arranging the reduction potential of different electrodes in increasing or decreasing order. This arranging reduction potential of different electrodes in increasing or decreasing order is called electrochemical series. Is called electrochemical series. ECS, electrochemical series. It is the arranging different elements in increasing order or decreasing order of that reduction potential, mainly taken as reduction potential. Potential may be reduction or oxidation, but only we will take in terms of reduction potential. This arrangement is called electrochemical series. For example, I will give some examples. The order is like this: F2 greater than Cl2, greater than Br2, greater than I2, greater than Hg2 plus, greater than Ag plus, greater than copper2 plus, then hydrogen, then your Pb2 plus, greater than Sn2 plus, then iron 2 plus, G2 plus, then aluminium 3 plus, Mg2 plus, sodium plus, then potassium plus, then lithium plus. What does it mean? Increasing order of their reduction potential, increasing order. But generally for hydrogen, E naught value of hydrogen, reduction potential of hydrogen to H, this one is taken as 0 volt. It's very important, this thing you remember. The reduction potential of hydrogen is considered as a 0 volt, and generally this is called, each one is called half cell. This is also one half cell, this is one half cell. When you connect any two half cell you connect, you will get a complete cell, electrochemical cell or galvanic cell. So each one is considered as a half electrode, that is a half cell for a particular cell. So generally the hydrogen is considered as a 0 volt, that is a reference electrode, that is called SHE, that is standard hydrogen electrode. Standard hydrogen electrode is conduct. It is this standard hydrogen electrode is just one. You can draw the diagram. This is one vessel made up like this, and it is connected to one and containing solution of 1 HCl. 1 HCl is taken. Then one tube is connected, inverted, and connected to platinum wire, and at the end it is fixed to platinum foil coated with platinum black, and the side of the tube where 1 atm hydrogen gas is passed through it. Continuously hydrogen gas will maintain the pressure of 1 atm inside the tube, and this tube is inverted and dipped in the 1 HCl solution, and the tube is fitted with platinum wire. At the end of the platinum wire, one platinum foil coated with platinum black. Platinum is fixed at the bottom. This is the one expression of what? One half cell, that is SHE. This is the standard hydrogen electrode. Its electrode potential is taken as 0 volt, and it acts as a reference electrode. When it will be connected to other electrodes, anyone, then it will be a complete cell. It will be a galvanic cell. So this is very important, that the representation of this representation, that like this, E naught H plus to H2, like this. It is expressed as H plus changes to H2, and here platinum. This is indicates for reduction, but it can be expressed like this, H2, then here PT, here concentration is 1 when PT H2 slash H plus 1 this expression indicate anode, and this expression indicate cathode. What does it mean? H plus H2, that is reduction, so acts as a cathode. H2 H plus acts as anode. So this is the representation of anodic expression and cathodic expression of SHE, standard hydrogen electrode. Both potential is 0. For both potential will be taken as 0. So this is the electrochemical series. Here written in which order? In decreasing order reduction potential. Only reduction potential. From fluorine to what? Lithium. Lithium has very low reduction potential, and fluorine has very high reduction potential. So this is the called electrochemical series. Then let us discuss what are the application of electrochemical series. Application of electrochemical series, first one is that calculation of E cell. Standard E cell, any cell has EMF value, electromotive force or cell potential can be calculated. E naught cathode minus E naught anode. For any cell, you can connect two half cell to connect two electrode, then it will be a complete cell. Then the standard cell potential is equal to E cathode minus E anode. All having some cell potential. But with hydrogen technology, or similarly, other different cell has different electrode potential. You can see the books, the series is given. So E cell, E naught cell is equal to E naught cathode minus E naught. Always positive side, because cathode is has greater reduction potential than anode. Second application is selection of anode and cathode. I can select anode and cathode. Here remember, anode means anode generally high tendency to lose, so low reduction potential. And cathode will be high reduction potential. Low reduction potential always anode and high reduction potential always cathode. For example, low reduction potential, suppose zinc. Zinc reduction potential is equal to, generally E naught value of zinc is 0.74 volt. That is what? Minus. That is minus 0.74 volt. 0.76. That is 0.76 volt. That is minus sign. This is for zinc. And for that, if it will be cathode, we can use that copper. Copper has high reduction potential, that is plus 0.34 volt. That is positive value. For copper is 0.34 volt. So you have to remember high reduction potential, that is cathode, and low reduction potential, that is anode. So in between zinc and copper, if you want to form one galvanic cell, zinc will be anode and copper will be cathode, because zinc has low reduction potential, that is minus sign. Okay, this is one important application. Third application is oxidizing agent and reducing agent. I can know which will be oxidizing and which reducing agent. Low reduction potential means tendency to gain electron is less, means it acts as a what? Low reduction potential means tendency to accept electron is low, and tendency to donate electron is more, means high oxidizing agent. Oxidizing character is more, but high reduction potential means tendency to gain electron is more, means that is your what? Low, just I am repeating again, low reduction potential means tendency to accept electron is low, means tendency to donate electron is more, that means high what? Here just 1 minute. Low reduction potential means tendency to gain electron is less, but tendency to donate electron is more, means high what? Reducing character, high reducing agent, high reducing nature, means reducing agent will be more. Low reduction potential means high reducing character. High reduction potential means high oxidizing character, high oxidizing agent. High reduction potential means higher oxidizing agent. Low reduction potential means higher reducing nature. So reducing nature, oxidizing nature you can know from this potential. Low reduction potential means high reducing nature. High reduction potential means high oxidizing nature. So selection of anode, cathode, oxidizing character and reducing character, and calculation of cell potential. First one is we can do that what? That reactivity of metal and non-metals. Generally, low reduction potential means more reactive. Because they have high tendency to lose electron. Low reduction potential means high tendency to lose, that's a more reactive metals. And high reduction potential will be more reactive non-metals. This first one is metal, this is your non-metals. So this is the very important concept. When we are discussing between metals, low reduction potential will be more active. When discussing the non-metal between non-metals, then high reduction potential will be more active. For example, fluorine is more active than chlorine because fluorine has high reduction potential. But between suppose sodium and zinc, sodium is more active than zinc because sodium has a low reduction potential compared to zinc. For example, you can say zinc is more active than copper. Already we have taken. Zinc has minus 0.76 volt and copper has 0.34 volt. So zinc is more active than copper because zinc has minus reduction potential. Low reduction potential means more active. So these are some important application of electrochemical series. Okay. So in the next class we will discuss regarding that product of electrolysis, how can we get different types of product on the basis of their reduction electrode potential. Okay, thank you.